We are hosting this webinar at the Hopland Research and Extension Center, which is located in Hopland, California, and it's part of the University of California's Agriculture and Natural Resources program. Our mission here is to maintain and enhance ecosystem integrity through applied research, educational activities, adaptive management, and supporting working landscapes. We're also honored to be on the ancestral, traditional, and unceded lands of the Choctaw and Hopland people. We feel so grateful to work, educate, and learn here on these historical lands of the Hopland Pomo people. So tonight we're joined by Ted Grantham, who is a University of California cooperative extension specialist based in Berkeley. And he was also the lead author on the 4th Regional Climate Change Assessment for the North Coast region. So he's a great guy to give us some info about the future of our water systems here in California. And with that, I'll just go ahead and pass over to Ted. Thanks for coming, Ted.
Sure, my pleasure. Good evening, everyone. Yeah, so today I pulled together a presentation. I'm going to provide a little bit of an broad overview of California water, just to kind of set the stage, and then we'll dive a little bit deeper into some of the effects of climate change, focusing really on water resources and in the state and in Northern California in particular, and then provide some discussion of some of the adaptation strategies that are being considered, in statewide, but also in California. And so, as I mentioned earlier, I'm going to provide a pretty broad overview of sort of some of the issues that we're dealing with in California, and then do a little bit of a deeper dive on some of the climate change impacts on water resources that we're seeing and expecting to see in the North Coast region in particular. As I mentioned, I work at UC Berkeley, and joining you from Oakland, California, which is within the terrestrial ancestral territory of the Huchun, the ancestral and unceded land of the Chochenyo-speaking Ohlone people I want to acknowledge. So this evening, I'm going to just provide, again, kind of a pretty quick kind of California Water 101 overview for those of you maybe coming from outside of the area or just kind of interested in hearing what's happening at the statewide level. And then, like I said, we'll do a deeper dive into climate change, and then talk a little bit about some of the adaptation challenges and opportunities. And if you have to, jump off the call a little bit earlier, I just want to leave you with a few very high-level take-home points, in the sense that this presentation will kind of lead up to. And despite the current conditions that we're facing under the drought, Northern California is still, the most water-rich part of the state, which I think makes it somewhat more resilient to climate change in some ways, and more vulnerable in others, which I'll discuss. What we're seeing, some of the more sort of distinctive changes of climate change that we're seeing with respect to precipitation is the increase in variability, both seasonal variability and interannual variability, which collectively increase the likelihood of more extreme dry and wet years. This is coupled, that's precipitation variability is really coupled with these increasing temperatures that, coupled with precipitation, increase the frequency and severity of drought. And then won't go into a lot of details in terms of some of the adaptation options, but I think there actually are quite a few actions that we can and should pursue. A lot of opportunities around water conservation, improved flood and drought management, groundwater management, and ecosystem restoration that all will help to limit the impacts of climate change and enhance climate resilience, as well as have other benefits. As I'm sure all of you are well aware, we are in the midst of a very what's shaping up to be a very severe drought, which has caught I think much of California, and certainly its water managers, a bit off guard, despite the fact that we just came out of a multi-year drought just a couple of years ago. Unlike the previous multi-year drought, which affected the entire state, this drought has actually been probably more pronounced in the north coast than the previous drought in some ways. Although this map doesn't really necessarily represent that. Although you can see that Sonoma County is really in the hot spot, and as you know, the Eel and many of the other rivers are not in great shape. And so, yeah, I just want to acknowledge that, this drought is having real impacts on our communities and our environment. We're experiencing these impacts in many ways. Some are subtle and some are very disturbing. And I just want to acknowledge that, engaging with this topic, thinking about climate change and climate change impacts can be uncomfortable. And I guess I just invite all of us to kind of sit with this discomfort or any tensions that may arise. And hopefully we'll have an opportunity to kind of share what comes up at the end of this conversation or this presentation. So let me dive in. I'll start, again, with sort of a broad introduction of California's water. And, before we go there, I always like to even scale back even further and think about the Earth's water and sort of remind ourselves of what a precious resource this is. And so this map is one that was developed by some folks at USGS that visualizes sort of the world's water. And so in the large sphere over the United States represents all of the water collectively in the world, in our oceans and ice caps and underground. And then that smaller sphere kind of over Georgia or Kentucky, I guess, represents all the fresh water in the world. So this is all the water that's in groundwater, as well as surface water and in the ice. And that tiny little dot, which you probably can't see very well, I'll put my finger on it there. That's really what we're talking about today, which is the water that we find in our rivers and streams and lakes. So the surface water that really has a disproportionate importance for biodiversity, for the environment, and for people. So this represents less than 1% or less than 1/10 of the world's water, and covers less than 1% of the Earth's surface. But we know it's so important for both for people and the environment, and really kind of defines kind of much of our experience in California and supporting agriculture and vineyards and fish and wildlife, certainly providing water for cities and for the ways in which we often recreate. So there's a few aspects of water in California that really make it, I think, unique from other places in the United States. And this is owing to it's partly its Mediterranean climate, but so the unique geography of the state, where we see a really high degree of spatial variation in where precipitation and runoff, so which we call is basically what ends up being in supporting streams, where this occurs. And this is just one of the maps that shows this. And what this map shows is the areas in the state that are responsible for generating most of the surface water that we rely upon, that gets stored in snowpack, but also stored in reservoirs and flows through our rivers. And so what this shows here is that 66% of the water that is produced by the state in the surface occupies about 20% of the landscape, and that's shown in the blue here, and then or the purple, and the lighter blue is where some additional proportions. What you can see here is that almost 90% of the water that's produced in California, most of that's in the northern part, with the exception of some of the Sierra Nevada here, and a little bit on the coast range. So we have a highly sort of skewed distribution of where the water is from where most of the people are and where most of the agriculture is, right? So that's just something to keep in mind of what makes California unique and really is at the heart of many of our challenges. In addition to the spatial variability, we also live in a highly, seasonal and temporally variable climate. This map on the left is from Ukiah, I believe, which just shows average monthly seasonal temperatures and precipitation levels. And so this should come as no surprise, to anybody who lives here, but we have a highly seasonal climate. We get 90% of our precipitation between November and March typically, although that obviously varies year to year. And then this figure on the right, I like to show because it really highlights how unique California is compared to the rest of the state. And so this is a map that shows the high degree of interannual variation, so year to year variation that occurs in the state. So the darker the colors, the greens and the blues, shows that there's more interannual variability than the places that show the reds and the yellows. Yeah. So to our participant from Minnesota, interested in thinking about how California might be different, that this is one map that really highlights that, where in much of the the eastern kind of half of the United States, there's much less interannual variability and also less seasonal variability. So it's really these two sort of forms of variation, this highly seasonal and highly variable interannual precipitation patterns coupled with the spatial variation, that gives rise to this vast and complex network of dams and canals and diversions that move water around the state. And here's just one representation of California's sort of water management system that is designed to store and move water primarily from north to south. This water management system did not come about overnight, and it started very early with the arrival of European settlers in the 1800s. And the gold rush, I like to think that it was water was really at the heart of many of the activities that took place as European white settlers came to California. Water was used extensively in the gold mining process, both for sluicing, but also for this hydraulic mining that occurred throughout particularly the Sierra Nevada, where water was used to sort of blast hillsides to try to free up some of the gold deposits. And obviously water played a major role in what we call the reclamation and the sort of transformation of the Central Valley's great wetlands into agricultural lands. Coming from the North Coast, water also played a pretty important role in forestry, particularly in moving a lot of the timber that was cut through through these forests and through these watersheds and out to the ocean where they were brought to market. I could give a whole talk on kind of this history and on kind of the early uses of water, but I just wanted to touch briefly on kind of the water right system that sort of emerged during this period, because it still has consequences for understanding what's happening now and some of the challenges that we're facing. So originally, many of the early European settlers, really prior to the gold rush on the eastern seaboard, adopted a system of water management known as the Riparian doctrine, in which the rights to use water really came with proximity to a water course. And in places like Minnesota or the eastern seaboard, where you get rain year round, having access to a river would certainly be helpful, but it wasn't necessary for agricultural enterprises. And what's unique about this riparian water rights system is that the right to use water was restricted to those who had property adjacent to a river or stream. And so in this example here, a landowner on properties A and C could use the water, but not B. And what's also unique about the riparian water right system is that during a drought, so during times of water scarcity, the property owners of A and C would reduce use proportionally, and so they sort of share the burdens of reducing water use during times of scarcity. So this is quite different to a second water rights doctrine that was, I just have some animations there, that came from Spain, and this was known as, that should be the appropriative water rights doctrine in the title there. And so here, under the appropriative water rights doctrine, the right to divert, store, and use water really came based on its the time in which it was put to use. And so anybody showing up to a location that claimed a water right and started to put water to use could basically claim priority of use. And so in this example, if the individual who started farming parcel B, which is not connected to the river, would have the first priority of right, and then someone coming later, like person C, who would maybe built some storage and also irrigating the land, would have what they call a junior right. And what's really different about this system of allocation versus the riparian water rights is that during drought or time of water scarcity, the senior water right holder would get all their water first before the subsequent water rights holders. And so these two water rights systems were very much in conflict during kind of the early 20th century. And there was, court cases that emerged that, oops, about that, that tried to reconcile these two systems. And basically what we ended up with was a dual system of water rights that we still have today, where there are still riparian rights coexist with appropriative water rights. But in most cases, anybody, sort of, unless they have sort of historic right, riparian right, in most cases, appropriative rights are sort of the dominant way in which most of the, municipalities or agricultural uses are held in their appropriative water rights in the state. And there are a lot of them. And so this is just showing you statewide what the distribution of different points of diversion associated with these appropriative rights are. And the reason I'm not showing riparian rights is that the state has not actually done a very good job, or at least historically, of tracking and documenting these rights, because they're not subject to the same requirements as appropriative rights that were established, about after 1914. And so a few years ago, I did an analysis to try to understand, sort of how much water has been allocated through this water rights system statewide. And these two graphs kind of summarize these patterns. And so as you can see here, these are just the appropriative water rights that I'm looking at. Starting the appropriative water rights, the modern appropriative water rights system that we have in California was really started in about 1914. And what we see here is that starting in the 20s and 30s, these on this left graph, it shows just like the count of water rights, and on the right graph shows the total amount of water that's associated with these water rights, which is known as the face value allocation. It's just like the total amount of water that each water right allows you to divert if it's available. And this is in million acre feet. So these are large amounts of water. And so what you see here is that individuals and corporations sort of make up the majority of these water rights. And here in like the 1940s, you see a pretty rapid rise in the number of water rights that are being allocated, which is really when we started seeing the kind of expansion of some of the big water projects in the state. And here on the right, you really see the jumps in these big water projects. These are like when Shasta Dam and some of the big dams were installed in the state. And so the big take-home point here is, one, a lot of water rights have been issued. Most of these water rights are held by private individuals, but the bulk of the water that's been allocated is held by federal, state, and kind of quasi-public entities. Another important takeaway here is that when we think about the mean annual water supply that's generated by the state, like how much water does California in like an average year, say, generally generate? It's about 75, 80 million acre feet. And so what you see here is that the amount of water that's actually been sort of allocated or granted to the water rights system vastly exceeds the amount of water that the state actually produces. And I would argue this is sort of one of the problems that California has and this is in some of its regions, is that basically more water's been promised than is available. And we can look at this statewide and like kind of look at the spatial distribution of this. And so what we see here is that this graph just shows the actual rivers in the state that water, where water has been kind of over allocated, or when the water rights that have been granted to individuals exceed the amount of water that the river produces. So the rivers in blue are those where the water rights represent a very small volume relative to what's produced, whereas those in red, the amount of water that's been allocated to water rights meets or exceeds greatly the annual production. And so the Trinity River, for example, is one of the rivers that really stands out in the North Coast region, where much of the water that flows in that river has in fact been allocated to water rights. And so many of you may know that the Trinity River, much of the Trinity River is diverted over into Whiskeytown Lake and then brought over into the Sacramento River Basin, where it supplements water supplies from the Sacramento River Basin. We looked at other parts of the state, though. We also see high levels of water allocation, including the Sacramento River and the San Joaquin River. It's really extraordinary, and this, of course, is where much of our agriculture is concentrated and is often the heart of much of California's water conflicts. So the Trinity River, for those of you who don't know, as mentioned, is connected to the Sacramento River system, and was this project that was built to divert this water was all part of a large federal Central Valley project that was built in the 30s for a combination of flood control and water supply storage. And so that water from the Trinity, which is shown, this shows that the Trinity River project is part of this. All those in red are basically part of the federal Central Valley project system. So that water is very much managed to support irrigation in the Central Valley, in addition to producing hydropower and other benefits. So when we zoom into the North Coast region and its sort of the balance of use and supply, you get a slightly different sort of perspective. And this is a report that's put together, annual report that's put together by the Department of Water Resources, which is the state agency responsible for for managing and tracking water resources. They don't have the same enforcement role, and they don't issue water rights. That responsibility is held by the State Water Board. And so anyway, they do these water supply and use portfolios for every region in the state, including the North Coast region, which is shown in green in the left panel there. And so they characterize the system a little bit differently. So on the supply side, so looking to the right here, most of the water that is sort of being produced, naturally produced on the North Coast through rainfall and snowmelt, or is available in groundwater, is in fact, coming from local runoff production. So coming off from snowmelt and precipitation runoff, and a very small proportion is actually coming from reuse, water imports, and groundwater. So about 1% each for each of those, other sources. In terms of use, they consider water that's flowing in rivers that has some degree of protection, either as an in-stream flow requirement or with wild and scenic river status, as a use, though it's not exactly a water use. And what we see here is that of the water that's kind of supplied to the state, in the region, a relatively small proportion is actually used by people for sort of traditional activities, including drinking water and irrigated ag. But if we just look at the total, within this slice of the pie that's focused on human uses, we see that groundwater and surface water both play an important role. And so this map here shows the proportion of local water supplies of the water that's used for human economic activities or for drinking water, domestic use, and agriculture. We see that a pretty big proportion of water actually comes from groundwater sources, which historically has very much been overlooked and not well regulated. And in fact, it was only in 2014, in the midst of the last major drought, that the state passed major legislation called the Sustainable Groundwater Management Act to better regulate groundwater use. And this act basically requires the development of groundwater sustainability plans, they're called, for most groundwater basins in the state. It targets those that are they believe to be sort of over allocated or at risk. And I believe in the North Coast, the Eel River, the groundwater basin underlying kind of the mouth of the Eel is the only one, but in certainly the Russian River basin is included in that as well. And so what this new law requires is that groundwater be sustainably managed, and that is defined by the maintenance of groundwater levels that prevent seawater intrusion or the degradation of water quality, that prevents land subsidence, that prevents and avoids surface water depletion, because many times groundwater and surface water are highly connected. And so this act is currently being implemented. These plans are being put together by various entities. It's off to a fairly rocky start, but it's happening, and it's really has the potential to be quite transformative for our state, and actually play a really important role in the way that we adapt to climate change, which I'll talk about in a little bit. And in fact, that kind of brings me to the next part of of this presentation, which will indeed focus on climate change impacts. So for this part of the talk, I'm going to kind of do a deeper dive into climate change impacts on the North Coast, but again, really focusing on water resources, which is the main theme of this event today. And I'm going to be drawing primarily from this report that we developed as part of California's fourth climate assessment that came out about 2 years ago. And I was the lead author on this report, but was supported by a really a very notable group of collaborators and local experts that helped to inform and write many of the sections of this report. So this was by no means a solo effort. So what is the North Coast region that we're covering? Basically, it was these counties shown here from Mendocino up to Del Norte on the coast, and then Siskiyou, Lake, and Trinity counties. And I won't be getting into all the details here, but I just wanted to give you a little bit of a sense of the topics that were covered in this report. So we started with a fairly brief overview of climate change and the way in which human activity and the increased concentrations of CO2 in the atmosphere are causing changes in the global climate system, including these parameters shown here in section 2. And then there was discussion of sort of how these changes in the physical environment were affecting both natural systems, ecosystems, and communities in the region. So just like a little bit of sort of jargon that I want to cover, there's a term that's used called RCPs, or representative concentration pathways, that basically represent different scenarios of potential future scenarios of global greenhouse gas emissions. And so these scenarios are put together developed by scientists who kind of put their best guess on potential trajectories that our sort of global society might take in the future, including sort of a business as usual scenario, which is the higher scenario, this RCP 8.5, or scenarios in which sort of global societies sort of really make strong commitments to the reduction of greenhouse gas emissions. And so depending on which of these sort of scenarios is realized, you end up with different global average temperature changes, which are shown on the right. So obviously, the higher the concentration of CO2 in the atmosphere, or the more emissions that we put into the atmosphere, the greater the temperature change that we see. And so, yeah, if you're interested in sort of some of this basic science, there are other sort of reports and documents that I can refer you to. So now zooming into the North Coast and looking for towards some of the projected changes, we see, I'm showing here the sort of a moderate scenario in terms of greenhouse gas emissions, and then in the red is the more significant scenario. And so what you can see here is sort of bouncing around. These are the observed conditions, is in the black, and then the modeled future conditions are shown in the red and the blue. And so overall, what we see is under the high scenarios, our average daily maximum temperatures for the region increased by about 8 degrees by end of century, at least for, let's say, the coastal region like Humboldt County. These temperature increases aren't equal across, or are not the same across the region. We see basically the interior regions will heat up more dramatically than the coastal regions. The coastal systems the ocean will still have some sort of buffering capacity on increasing temperatures. So it's really, Siskiyou County, Trinity County, Lake County, they're going to experience the largest changes in temperatures over time. What does this mean for water resources? Well, one obvious, probably the most obvious and well-documented change in water resources will be shrinking snowpack. And so by mid-century, this is probably actually a bit conservative. We see that, a lot of the mountainous areas that support snowpack that contribute to our rivers and streams are going to either melt more quickly and hold much less water on average. So we're going to see sort of the conversion of sort of snow melt to rainfall driven hydrologies in a lot of our mountainous regions. One of the consequences of increased temperatures will also be a decrease in soil moisture. And so we're going to see actually higher temperatures. We're going to see increased evaporative demand from vegetation on the landscape, which is going to decrease soil moisture, which is likely, is not only going to sort of contribute to, sort of dry conditions that are promoting fire, like we're seeing today, but also, but over the longer term will result in sort of changes in vegetation communities throughout the area. And in terms of sort of extreme heat days, this is some projections show that, we're going to see dramatic increases in the number of days over particular high heat thresholds, which is obviously a big concern, not only for ecosystems, but also for people and human health. So unlike this like really clear increasing trend in temperature that is projected, we don't actually see a clear trend in precipitation, at least in annual precipitation. So these projections are showing that, for the North Coast region, precipitation is actually kind of bouncing around about the same mean value, average value. What's different though is that we're actually starting to see higher, more extreme variation in annual precipitation. So even if on average we get about the same on an annual basis, or I'd say over the long term, the interannual variability will be much higher. And so one of the sort of explanations for that is that we're going to see more extreme precipitation behavior. So we're going to see, when it's wet, that water that arrives is going to come in a more sort of dramatic fashion. And that's simply because at warmer temperatures, the atmosphere can hold more water. And so many of you have probably may have heard of these phenomena called atmospheric rivers. They're the weather patterns, the precipitation patterns that actually contribute most of the annual rainfall that we receive in California. And a handful of events are often responsible for the vast majority of the rainfall that we receive in the year. And whether we get an atmospheric river or not, whether we get 2 versus 5 can really make a difference between, a wet year or a dry year. And so we expect to see, in wetter years, much more of this atmospheric river activity delivering more water. And so we're going to see an increase in the amount of water that's delivered in a relatively short period of time, which is, clearly problematic when we think about, flood risks, and also our ability to actually utilize that water. Because if all of our water comes, on just a few days, our systems, our reservoirs are going to be kind of overwhelmed. We may not actually be able to store as much water as we would if that water was delivered, little by little over a longer period of time. And so collectively, what all this means is that we're kind of facing a future where we can expect to see both more extreme dry years as well as extreme wet years. And a climate scientist, someone named Daniel Swain, put this graphic together and described this phenomenon as climate whiplash. And so rather than sort of having, what we might consider an average or a normal year kind of bouncing around, and then with occasional disruptions of very wet years and very dry years, we're actually probably going to be bouncing around between very wet years and very dry years. And the average year is probably going to be, the normal year, if you will, is probably going to be the outlier. And so what this map is showing you, that in Northern California, the frequency of extreme dry years like we're experiencing this year are going to happen about twice as often as they have historically. And the likelihood of extreme wet years are going to happen a little over twice as often as they have historically. And we're going to see some increase in this likelihood of sort of flipping back and forth between wet and dry years. Many folks on the North Coast who particularly spend time in the coastal belt are often curious about fog, which is a really important source of water, particularly for our vegetation. And the data right now are really uncertain as to how climate change will affect our fog patterns. There have been just a couple studies, one of which suggests that the occurrence of fog, or the number of fog days along the coast, is decreasing. There's another where it's not as clear. So this is a very active area of research. Fog is affected by a lot of different factors. It's affected both by what's happening in the inland system as well as what's happening in the marine environment, and it's actually shown to be quite difficult to predict and really model the fog in the environment. So scientists are still trying to figure out what climate change may mean for fog patterns, and also for many of the forests that depend on fog in the future. One thing that is clearer is trends in stream flow. So as I mentioned, with these sort of more compressed and intense winter seasons, coupled with this increased temperature, we're likely to see decreasing dry season flows and potentially actually higher wet season flows. So this graph is just showing across a broad suite of future climate projections how monthly stream flow may change in the North Coast region. So you see that most of the models indicate that flows in sort of December, January, and February are going to increase, again, probably as a result of this more intense rainfall occurring during those periods, as well as the loss of snow, which is now being delivered in the wet season and rather than in the early spring, and then a decrease in stream flow conditions starting in May through August. And so obviously this is of concern, not only for people who depend on streams for water supply, for recreation, but of course for fish like salmon that are also going to be experiencing higher temperatures. I just wanted to throw this up too, to show that currently this is as of today. This map is showing all of the relatively long-term stream flow gauges from the region, and basically those in red are the daily observed values. The conditions that are observed today are either less, for many of the gauges in the North Coast, are either less than the 10th percentile. So that means over the entire period of record, less than 10% of the time have flows been this low for this day. And those in the brighter red are showing a record low. They've never observed a flow this low on this day in the past for many of these streams. And this sort of underscores, basically what characterizes these types of droughts, and is consistent with our understanding of kind of a warmer climate future. So, I'm gonna just maybe leave the discussion of the sort of these physical changes there, and just talk a little bit about kind of some of the consequences of these changes. First, for ecosystems, clearly this means that these changes in the physical environment and vegetation and so forth are going to be problematic for many of the species that depend on those habitats, particularly cold water species like salmon and steelhead trout, that are going to have to deal with both changing flow regimes as well as water quality degradation. So of course, we're going to see increasing water temperatures, as well as increasing things like harmful algal blooms that are starting to become a real problem for a lot of our Northern California rivers. There's already been previous talks that have addressed fire risk, so I won't talk about that a lot today, but that's clearly a product of these sort of drier soil moisture conditions and longer dry seasons. And of course, for working landscapes like rangelands and pasture lands, this sort of drier conditions is also very, very problematic. So over the longer term, in terms of like potential vegetation shifts, I think it's like a little bit up for debate. I think what some suggest is that higher fire frequency are going to reduce tree densities, and we may actually see a conversion from sort of more conifer dominated systems back to oak woodlands that are a little bit more tolerant of water stress. But that's really going to depend on sort of how we manage these forest landscapes and ability to do prescribed burning and some of these other methods. In terms of community impacts, just like this is very brief treatment of a very big topic. Many of these changes in the water cycle, in the water regime are going to threaten infrastructure, particularly from flooding, but also coupled with sea level rise. And these are threatening both our transportation, water supply, energy, and communication systems. Obviously, there are a host of public health risks associated with these changes. And, just something that I always want to just, hit home is that, these impacts are going to be felt first in the most significant ways in communities that are already highly disadvantaged and struggling. And so, while many of us may feel that these impacts are still somewhat abstract, I think it's important to note that many people are already feeling some of these effects, and they absolutely deserve attention and resources. So on that, depressing note, I want to actually change to maybe a little bit more, finish on a little bit more of an uplifting set of topics, and just acknowledge some of the strategies that are being pursued, statewide, but also in the North Coast, to adapt our system to these changes in the environment. I'm going to focus more on adaptation than I am on mitigation around what we do with climate change, just because of the nature of this talk, but happy to talk about that as well in our discussion. So I just want to highlight a few, strategies that are being sort of explored, and these are not exhaustive by any means. So certainly, water conservation is going to be more important than ever, right? And I'll describe that in a minute. Flood and drought preparedness is going to be critical. There's a lot we can do to restore ecosystems, to improve their resilience to climate change, and governance. The way that we manage our system and make decisions and invest resources. That the importance of that can't be overstated. So just briefly on the water conservation side, and again, I think we were hoping to sort of bring maybe some folks in that might have be more actively involved in sort of on the ground conservation projects, but just wanted to sort of touch on a few issues. So obviously reducing our water demands is just an obvious one, right? And we still while I guess I'm guessing that many of the people in this room already do a pretty good job of conserving water overall in California, Northern California. We still have a long way to go in terms of the way in which we use water, particularly in households, and in landscaping for that matter. And as well, this again could be another talk. Water reuse is actively being pursued in other parts of the state where water is more scarce, and there's a lot of really exciting, I think, technological developments happening around that. Particularly with gray water and recycling the wastewater, treated wastewater. One thing I've seen a lot on the North Coast and a lot of interest in this is around increased use of rainwater catchments, or if not just rainwater catchments, at least off-stream seasonal water storage, like you see here in this photo. And it's just sort of the more we can put these types of projects in the right places and fill, with some, guidance and restrictions to avoid environmental impacts, allow them to be filled in the winter when water is plentiful. This can be a really important way of limiting our water use pressures on our rivers in the dry season when flows are naturally so low. And then finally, I just wanted to hit on accounting, the importance of water use accounting. And I think, we might all have the impression that the state is, sort of tracking how water is being used and how much water is available. And unfortunately, that's just not the case. And there's still a lot of uncertainty in how much water is being used across the landscape, which really gets in the way of our ability to sort of manage the system in a way that's most efficient and keeps as much water as possible in stream to support environmental uses. And one example of that is cannabis cultivation. And this is another area of my research where there's a lot of uncertainty, a lot of anecdotes around how much water cannabis is using. And certainly there's a lot of research happening in this area, but it's not just cannabis that we need to get a better handle on. It's also domestic water use and other forms of use in the North Coast. And again, if those of you have questions about cannabis in particular, happy to take those at the end of this talk. Just a few more slides here. Flood and drought management are both really important. After the last major drought, it became very clear that our state agencies and many of our local agencies were not prepared for a multi-year drought. And we thought we had learned from that experience. And it turns out that given where we are now, we still were kind of caught off guard by the current drought. So there's a lot that needs to be done in the drought planning arena, so that as drought conditions develop, there's sort of a clear understanding of how we collectively are going to respond to avoid sort of the worst impacts of that, both on the environment and on communities. One area in the flood domain that's been pretty exciting is that what we're seeing is, I mentioned earlier, the importance of these atmospheric rivers in delivering water supplies. And what we're seeing is actually technological developments that make it possible to forecast the timing and the amount of water that's going to be delivered to different parts of the state with much more accuracy than in the past. And these technological developments are going to allow us to manage our systems in a way that basically allows us to store, sort of more of the water that's delivered, and give us more operational flexibility. Because currently what happens, at least for our large reservoirs, is that if they think that there's a big storm coming, they'll actually empty out a lot of the reservoir to provide enough storage space so that when the big storm comes, the reservoir isn't overwhelmed and caused and that, so it doesn't lead to downstream flooding. But if you have a better sense of exactly how much water is coming, or at least a better sense of how much water is coming, you can avoid releasing more water than is necessary, and you'll end up with higher storage water supplies at the end of the wet season, or going into the dry season, than you would otherwise. And so a lot of really exciting research happening in that domain, particularly in Sonoma County, but also in some of the Sierra Nevada watersheds. Finally, I wanted to mention this idea of managed aquifer recharge. And this, I'm not sure if this is as relevant or urgent for the North Coast as it is for other parts of the state, but I mentioned groundwater earlier and this Sustainable Groundwater Management Act. In parts of the state, including the Central Valley, we've seen a dramatic and steady decline in groundwater levels. And basically, historically, whenever there was a drought and surface water supplies were limited, everyone would move over to wells and just dig deeper wells and pump more groundwater. And eventually, wells were running dry, particularly those in disadvantaged communities, or run into water quality problems, and clearly it was not moving in the right direction. And so one of the goals of Sigma was to establish restrictions and more regulations around groundwater use, but there's also been this idea of managed aquifer recharge, which is, let's, in the wet season when water is abundant, let's find ways to actually get more water into the groundwater system and actually replenish those groundwater levels. And this can be done in passive ways, like getting water onto floodplains, or in more managed ways, like actually using injection wells. And so this is getting a lot of attention because we know that building more dams is actually not going to help us in California. And arguably, the reverse is true. We probably should be taking dams out. And that's just because any place in California where a dam might be economically beneficial, it's been built. We have thousands of dams in the state, and making them bigger to accommodate the 1 or 2 years in which we have enough water just doesn't make a lot of economic sense, especially given the other problems associated with dams, environmental. We lose a lot of water through evaporation. groundwater makes a lot more sense, right? Because you can actually get that water into the ground. It stays in the ground. And there are other challenges associated with that, but that's really where the state needs to go and figure out ways to accelerate these types of groundwater recharge programs. Other adaptation strategies include ecosystem restoration, and so our ability to for the environment to withstand climate change, we need to make some changes, and dam removal, such as what's happening on our plan for the Klamath very soon, is going to be really important for giving these ecosystems an opportunity to sort of adapt and respond to climate change, and hopefully give many of our species, like salmon, a chance for survival. Floodplain restoration is really important too. Many of our rivers have been sort of disconnected from our floodplains, and if we can reconnect those floodplains, it turns out we can provide some of these other benefits like groundwater recharge, but also help restore healthy rivers. And I just want to mention also the importance in growing recognition of the knowledge that Indigenous communities bring to land stewardship in a changing climate. And we see this in particular with practices that are really being embraced now, or starting to be embraced, I should say, with prescribed burning as a critical strategy for preventing high severity fires in the state. And so, but also not just around fire, but also around water, around other forms of natural resource management, around fish population, et cetera. So I think there are a lot of opportunities here to let tribal voices really lead the way in terms of our way climate adaptation strategies are developed. And just finally, I wanted to mention the importance of governance and the need to really bring together groups at the watershed scale to facilitate planning, assessment, and advocacy. And this is very much happening in the North Coast, both through watershed groups, but also through organizations like the North Coast Research Partnership that are trying to sort of leverage the capacities that exist to really put the region on track for adapting to climate change, for promoting sustainable economic activity, and restoring the environment. So that brings me to the end of my talk. I've covered a lot of ground, and I just wanted to kind of revisit some of these talking points here. I don't need to read them out loud, and I think I'll conclude there with some time for discussion. So thank you all for the attention and for bearing with me.
Thanks for that, Ted. That was really informative. I definitely just learned a few things and have a couple questions I could ask. But before we move into the Q&A, I wanted to mention that the Hopland Research and Extension Center will be hosting a class called Climate Stewards in the fall. And it basically looks at how to communicate about climate change. And throughout the class, you learn a lot about the details and dynamic nature of climate change. So if you're interested in going deeper in that, I really encourage you to sign up for our Climate Stewards class. I just finished a Climate Stewards class actually at the Pepperwood Preserve, and it was really excellent. So would recommend. And after that, I'd love to hear some questions. Does anyone in the audience have a question they'd either like to type in the chat or raise their hand? I see Eileen, go ahead. Feel free to unmute.
I have several questions, but the one strong question that kept coming up is, if we do rainwater catchment, doesn't that affect groundwater, and isn't that a problem for the aquifer?
It really depends on the location that you're in, with respect to and the volume of water that you're talking about. In most cases, the demand that people have on the landscape, let's say for just domestic needs or even for small scale agricultural needs, is a very small proportion of the water that's actually coming off the system in the wet season. And so in most places in the region, I would say the fraction of water that's not making it to the groundwater is probably not a big concern. Though there might be some local circumstances in which that isn't true. So
I see other people with questions. I have several, but I guess I'll just ask this next one. I saw on one of your graphs that you had kind of a separation in October, and I think on the Russian River system, there's a delineation of October is the rainy season. Well, it's no longer the rainy season. We don't tend to get rains until sometime in December. Is that being altered or amended or looked at?
Yeah, I mean, so historically, October has always been used as the start of the water year. And many places in California, you don't actually get much precipitation in October, but that's sort of just like kind of a convention of California waters. We use the water year from October to September 30th. But yeah, you're right in that one of the things that we seem to be observing is a sort of compression of the wet season. And while in the past we may have gotten some early storms and starting probably in November, sometimes in October, but probably mostly in November, that's moving, that the start of the wet season seems to be moving later and later. And then there are some years where it seems like we don't get our first major storms until January, right? Which would create huge problems for things like migratory fish that are trying to move back into the system. So I don't think there's any sort of discussion of sort of changing our the conventions around what defines a water year, but there's certainly a recognition that these precipitation patterns are changing, and our definitions of the wet season might need to change accordingly. No, I mean, it's a great question. And I think, so, I mean, 5 years ago, or I guess 7 years ago now, I mean, this groundwater legislation didn't, was just passed, right? So this is sort of a new, it's a new adventure that California is embarking on, and one that's like long overdue to try to get a handle on groundwater, and what sustainability really means. And it was a big fight, and it wasn't a foregone conclusion that this legislation would get passed. But what you're seeing, unfortunately, in many parts of the state is that exactly what you're explaining is that many of the agencies that are responsible for putting these plans together are using fairly rosy projections of how much supply is available, and taking some liberty with the models that are used there to basically make to lighten the load, the pain of actually adapting to sort of the reality that this is a finite resource. And so hopefully over time, the way that SGMA was structured, and this is very much we don't know how it's going to turn out. It's actually this drought, if this drought goes on for another few years, it's going to be really problematic, because it's going to make it's going to make the SGMA that much more difficult to actually achieve its goals. Like, we really need like 10 wet years to really get on track with SGMA. But if the environment gives us these dry years, it's really going to make it more difficult to comply with SGMA. Now, the state can come in; they have the authority to come in and say this plan's not good enough, and we're going to take over. And the state doesn't want to do that, and none of the local agencies want them to do that. But there is that stick that comes with SGMA that might move us in the right direction. But it's going to take a little time. But I think it's something that the community needs to be paying attention to. Yeah. Cannabis policy is something that's just, I think still taking form. I mean, for any grow that has a permit is required to submit, reports of their water use, their water source, and their cultivation practices, essentially. I think we're gonna, over the next couple of years, we'll see a little bit more attention, I think, around the environmental sort of in-stream flow requirements related to cannabis, and so ensuring that cannabis, they're already subject to what's called a forbearance agreement, where they're not allowed to divert from surface water in the dry season. But what we're actually seeing is that most cannabis users are relying on wells, and those wells are, again, so if you're the groundwater, this goes back to groundwater. Groundwater Sigma only applies to these relatively large groundwater basins. It doesn't apply to the types of wells that you see in these kind of upland watersheds. And many of these groundwater wells are actually pretty shallow wells that are located conveniently near a stream. And the state has actually not taken a very active role and stance in regulating those types of water use practices and really addressing the potential impacts associated with these sort of near stream, groundwater, coupled groundwater surface water diversions. And I think that's really where we need to get, what direction the state needs to go, both not only with cannabis, but also with, the many other groundwater users. Generally, the cannabis is subject to much more stringent requirements than other agricultural crops. Just because when cannabis was legalized in the state, they developed this new, sort of permitting system that was totally unique to cannabis, whereas many of the other agricultural commodities aren't subject to the same stringent requirements. And I think it's also true that, cannabis overall uses a very small fraction of water compared to the demands of vineyards in the region. It's really a drop in the bucket. Although that doesn't mean that impacts aren't a concern. It should be put into perspective, though. Yeah, I mean, again, it's a little difficult to generalize. I would say that, so we have a lot of dams in California that don't provide any water storage benefits, that either are small hydropower projects or have basically backfilled and lost their, are no longer sort of functioning, and are creating problems for the environment. And I think it's hard to give an argument for preserving those types of dams. I don't think that I honestly don't know all the details of the Potter Valley, project. I mean, my impression is that it's really the diversion of water, from the Eelt into the Russian that's so important for the Russian River, and that's it's a hydropower project, but really it's delivering water. How much the removal of some of the dams in the Eel would threaten water security of users, I really don't have a good sense, but I think there's a lot of dams that absolutely could come out and not have any impact on water security.
We've got a couple questions in the chat as well. I love that distinction between different types of dams. Every different situation can be so unique and dynamic. It's a lot to think about. Let's go for Jessica's question. She said, I live in Round Valley and would love to know how we can tap into assistance for assessing our groundwater supplies here in the valley. We're 100% on wells here, and it sounds like we have some people with wells going dry already. We have a very small water district with just one part-time manager on contract.
Yeah, I mean, in theory, the state water board, should have resources to support communities in complying with Sigma, particularly where you have communities that rely on groundwater and whose water is threatened by drought and unsustainable groundwater use. So I'm familiar with some programs, and could direct you. Maybe you can email me offline and I can try to direct you to some of the programs there, but it's not exactly I'm not exactly familiar with like individuals that could help. But I know there are programs that do exist that are designed to support both with the Sigma process, but also particularly with water supplies to disadvantaged communities.
And if you send that to me as well, Ted, I can send that around to everybody after the event. We'll do a follow-up email. Sure. So we have a lot of questions, which is awesome to see. Mm-hmm. I think next we'll have Jim, and then we'll move back into the chat. There's a question from Deb, and then Nancy, and then we'll go Jessica and Dan. If we have time, we've got we've got about 11 minutes, so we'll see what we can get to.
Thank you. I was wondering, as far as water rights, where do the indigenous people come into play in that? I know that there are still a lot of lawsuits with water rights out here in Southern California, I imagine in Northern California as well. Can you elaborate on their water rights?
Yeah, well, it really depends on, where you are in the state, but many tribes, at least federally recognized tribes, hold federally reserved water rights that are associated with their, they're often their reservations, and those should have priority to other water rights in terms of the obligations to meet the federally recognized tribal water rights should be met first before other water rights are satisfied. But that has not been done consistently in the state, which may not come as a surprise. And what it seemed, my impression, at least, and this is not my area of expertise, is that it really depends on the nature of the sort of the agreement with the sort of the federal agreement that recognized the tribe and the reservation, and the sort of the capacity of the tribe to actually exercise their legal rights, which we also know vary greatly across the state. So those tribes that are more well resourced have had sort of more success in getting their rights recognized in court, while those that aren't have struggled more. So I'd say it's been pretty inconsistently applied across the state is my impression, but again, it's not my area of expertise.
Also, I wanted to thank you for pointing out the value of TEK, and in regard to cannabis, I think I had read one of the studies that I think it was from 2016, or I don't know, around the time of Prop 64. I guess the information on the use of water came from the Growers Association, and now that's very inaccurate. Like you're saying, you're trying to actually put that into perspective. Now, what the studies you're doing, though, are those all outdoor grows? Because my concern over here in Southern California is we're growing in the middle of the desert inside, and it's just not really sustainable. And I don't know if anybody's really doing studies out here as opposed to Northern California.
Yeah, it's tricky. We're aware of those issues in the desert, and we haven't been able to get great data on that, but it's something that we're starting to explore. Most of the work that we've done has focused on water use in either outdoor, fully outdoor, or kind of greenhouse, hoop house type situations, mostly in the North Coast, but also the Central Coast. And so, when it comes to sort of more indoor grows in different climates, we're still, I guess, sort of struggling to understand how much water is being used and what the potential impacts of those might be on water resources.
Thank you.
So the next question is from Nancy. She said, when I drive through the Central Valley and even down the 5, it seems like almond trees are going in everywhere. I see orchards being flooded or watered in the mid-afternoon on 100-degree-plus days. Since most water goes to agriculture, how will the ag industry be required to improve their efficiency?
Yeah, well, that's a big topic. So, and most of the Central Valley is underlaid by a pretty, by groundwater, and they're absolutely required to comply with SGMA. And it's really the issues that have emerged there that, kind of drove the development of that law. And when you just do the math of like how much water we can expect to be available in any given year and how much ag is out there, there's general consensus that probably 1 million acres of crop need to come out of production. And so there's, that's easy to say. That's what sort of the economic models and water models show. What that looks like is sort of anyone's guess. There's, I don't know, 1 million acres, 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 1 million acres so that's just, I guess that's just one point to make, that yeah, current water use practices in the Central Valley are not sustainable, and change is coming. And whether that change happens in a, you know, organized, coordinated way or a haphazard way is the question. With respect to efficiencies, you know, there are, you know, strange as it may be to see, you know, flooding irrigation on a hot day, there certainly are a lot of losses there, but there are, where you're flood irrigating in many of these places, you're actually getting a lot of that is going back into recharge. I think there's probably a lot of, you know, maybe 100 degree, the hottest days, you probably shouldn't be doing that, but there's actually some context in when flood irrigation is sort of a less egregious practice than we might otherwise assume, because we are actually a substantial fraction of that water is going back into the ground. And then the question about whether we should be growing, you know, acres and acres of almonds, I guess I'll leave that to others to answer.
Yeah, that's interesting to hear that flood irrigation can actually help with groundwater recharge. I didn't know that.
And with the buildup of salinity, right? Because one of the big issues in the Central Valley is that you have these, if you use like really high efficiency irrigation methods, you tend to over time concentrate a lot of salts on the surface, and you know, applying more water can actually help flush some of those salts out and maintain soil quality. But
it's interesting. All right, so we've probably got time for one or two more questions. I think next up was Jessica. She has her hand raised.
You kind of covered my question, so I'll let someone else go, but I did want to just add real quick that as you were talking about the cannabis and the regulation of the water, that's for permitted cannabis, and that is a sliver of what's actually happening up where we are. We have vast amounts of unregulated cannabis, which means lots of unregulated water use and lots of water trucks, and no backup plan for these people with short wells. So super crucial. And I look forward to following up with any help you can provide us on linking us with people who can help us assess our groundwater, and any kind of advocacy as well, maybe. And also the understanding the rights of tribes, water rights, particularly the Round Valley tribes, because we want to, you know, work in collaboration and be sensitive of that as well. So thanks.
Great. Thanks, Jessica.
Awesome. Let's hear from Sally.
Hi, good evening. I thank you for the presentations. It was very, very interesting. And I just had a couple of thoughts that I'd like to hear what your thoughts are, Ted, on not only the Delta Conveyance Project and you know, how that is not supposed to affect the northern region, but it's kind of hard to understand how it would not affect the northern region with that project. And then another thought too is, as climate change becomes worse and worse, and you know, water becomes more scarce, are there any technologies that you're aware of where salt water from the ocean is being reused? I think it was the term I heard was recellulation or something like that.
Yeah, desalination. Yeah. So yeah, I can take a crack at those. So I guess with the last question first, yeah, desalination technologies is absolutely you know, improving and becoming much more economically viable for municipal water supplies in Southern California. So we're never going to use desalinated water to grow crops, which is still, you know, accounts for 80% of our water use in California. So there are certainly you know, places where desalination like is actually becoming you know, as economically, you know, sort of it costs the same to desalinate water as it is to, say, get water from the Colorado River Basin if you're LA or San Diego County. And so I think we're going to start seeing that. We're also going to see a lot more water recycling. So taking advantage of you know, doing better stormwater capture, but also dealing with treated wastewater tertiary water treatment to put on landscaping and potentially even all the way back to drinking water quality. So yeah, and those technologies are all improving and are going to be really critical for I would say sort of drinking water domestic uses, like domestic uses generally, but not for ag. For ag, it's never going to be economically viable to use those other sources. Yeah, someone mentions the cost of desalinization. Yeah, desal definitely has environmental impacts that we need to be concerned about. We can talk about that later. So your other question about, and we're about pretty much out of time, the peripheral canal. So didn't have a chance to really talk about the role of the Delta in California's water management system, but I showed those maps of California where we're moving water north to south, but where sort of all the action happens is in the Delta, which is just east of the Bay Area, east of the San Francisco Bay, where there are these two massive pumps that take mostly Sacramento River water, and water that's draining from the Sierra, and also water that's brought over from the Trinity, and sends it south. And the Delta is sort of the linchpin of California's water delivery system to the San Joaquin Valley, to Southern California. And it's a very fragile system because the Delta is sinking, sea level is rising. We have a lot of levees that are going to fail in an earthquake, and it's sort of a disaster waiting to happen. And so there's also a very sensitive and collapsing ecosystem. So in response to that, there are proposals to build what's been called the twin tunnels or the peripheral canal in the 70s, and which is basically a strategy to take water from the Sacramento River, probably somewhere, I think south of, not as high as Red Bluff, but somewhere in the Sacramento River where it's still fresh, move it around the Delta, around the foothills of the Sierra, and bring it down to those pumps to bypass the Delta entirely. And historically, the original plans for this were it was seen as basically a water grab from Northern California, because right now the ability for Southern California to pump water south is really constrained by requirements in the Delta and the need to maintain the Delta, the fresh water in the Delta. And trying to make it too complex, but I guess to get to your question, I think the critical issue. I honestly think that at some point, some form of that project will be built. I think the issue is going to come down to the size of the project. And I think what Northern California will need to do and what environmental interests will need to do, will need to fight to make sure that system can only convey, is a sort of as small as possible, so that it's still going to be useful in an emergency situation, but isn't so big that you're just going to invite more and more water to be sucked from the Sacramento River system. That's my general opinion. But I think we probably need to stop there. I think my contact information will all be on the website for this talk, and happy to take any questions via email that you all may have.
Awesome. That's good to hear, Ted. I'll make sure to include your email in the follow-up after this event. And I also have copied and pasted all of your questions out of the chat, so I'll try to address them in the follow-up email as well and see if we can get some answers to those questions we didn't get to tonight. Thanks everyone so much for showing up. We really appreciate you all. I know there's a few faces in here that have been to all the NorCal Climate Future webinars. We appreciate you. Thanks for your interest. You would probably be a star climate stewards student. So feel free to email Hannah Bird. I put her email in the chat, and I'll include it in the follow-up email as well. If anyone's interested in joining us for that climate stewards class, we'll go even deeper than we did in this webinar series.